Welcome everyone. In this video I am going to talk about the very important central limit theorem, and I will be solving 5 problems related to it so that you are very clear about the concepts related to the central limit theorem. In case if you are new to the channel, you should subscribe it. Here you get good quality video content. So first of all, I will look at the different forms of central limit theorem mathematically, and then I will explain the things through the problems. So the first statement is that if x1, x2, xn be a sequence of independent random variable with expectation of xi is equal to mu I and variance of xi is equal to sigma I square, means it is given that expectation of x1 is mu1, expectation of x2 is mu2, and so on, and it is also given that variance of x1 is sigma 1, variance of x2 is sigma 2 square, and so on. And if we define Sn, which is the sum of n such random variable x1, x2, xn, then under certain general condition Sn follows a normal distribution whose mean is sum of mu i's and whose variance is sum of sigma i's square as n tends to infinity. So basically, if I talk about this statement, what it tells you that for larger values of the sample from any population, it usually follows a normal distribution. Let me look at another form and then I will explain it further. So another form is that if x1, x2, xn be a sequence of independent identically distributed random variable with expectation of each of these xi is equal to mu, right? Here each of these xi's were having different mean, but here each of the xi has mean mu and each of the xi has variance sigma square. Then if we define Sn, which is the sum of n of these random variable, then under certain general condition Sn follows a normal distribution. This is the main point, with mean n into mu and variance n into sigma square as n tends to infinity. So you see, these are not two different results. Here we are taking the sample from a population in which each of the random variable has a different mean, but here the random variable are independent and identically distributed, means each of the random variable have the same mean. So if I talk about a corollary of this, it is telling you that if you take x bar, so x bar is what? The mean of this x1 plus x2 up to xn by n. Then what is the expectation of x bar? Then the mean of this will be mu and variance of x bar will be sigma square by n. We have seen this result earlier also, that here earlier I have talked about this in context of normal distribution, but here I am talking about any distribution, and I am suggesting that if n tends to infinity, means for large values of sample or for large sample sizes, the x bar which is the mean of the sample follows the normal distribution with mean mu and variance sigma square by n. So if I can summarize this whole slide in just one line, what is that conclusion? The conclusion is that if you increase your sample size, you will get normal behavior of the random variable. This is very natural also, right? If you notice someone for a longer duration of time, you will notice that he will show some sort of normal behavior, right? Sometimes he may be angry, sometimes he may be very happy and all, but over a longer period of time you will notice that his behavior is very much similar to a normal behavior. Okay, now in case if you might have not understood till now, these problems will certainly help you to understand, and I have chosen very good 5 problems from different textbook so that you will be able to understand it better. So this is the first problem, that let y is equal to x1, x2, x15 be the sum of random variable of size 15 from the distribution. So these x1, x2, x15 are coming from the distribution whose density function is given. What is the approximate value of this probability that y, this random variable, which is the sum of the random variable x1 up to x15, so what is the approximate value of this probability? And what we have to do, we have to use the central limit theorem. See, you may say that here the sample size is of 15, so will it show the normal behavior? It will show the normal behavior, but if we increase it to a larger value, certainly it will show better normal behavior. But in the question they have stated that we have to use the central limit theorem, so I am going to use. So before I use the central limit theorem, and I want to actually show that y follows a normal distribution. Y follows a normal distribution. But I need to find out that what will be the mean of that distribution and what will be the variance of that distribution. But to find the mean and variance of the random variable y, first of all, we have to find the mean and variance of the random variable x, because in the question they have not provided us the mean and variance, rather they have provided us with the density function. So in our earlier videos we have seen that if density function is known, we can find the mean and variance. So this question can also be asked directly, that find the mean and variance. So how do you find the mean? If I call mean as mu, then mean is the expectation of x, and it is calculated. So x into f of x dx, this is how it is calculated. And here you can see that the random variable x can take value between -1 to 1. So I will calculate it -1 to 1. Here it is 3 by 2 x square and into x. So it will become 3 by 2 x cube dx. And you can clearly see that this is an odd function, so its integration will be 0. But I am not using that property, some of you might not be aware. So I am integrating it -1 to 1. So if I put the upper limit, it will become 1 by 4, lower limit, it will become 1 by 4. So the mean of this distribution, that random variable, that is x, is equal to 0. And what is the variance? How do you calculate sigma square or the variance? So to calculate the variance, you calculate the expectation of x square minus expectation of x whole square. So first we need to calculate expectation of x square. So how do I calculate? It is equal to x square into f of x dx, and the limit of integration is -1 to 1. So it is -1 to 1, and if I multiply it by x square, I will get 3 by 2 x to the power 4 dx. So that I will get 3 by 2 x to the power 5 by 5. This is 5. Let me write it slightly better, otherwise it is not looking like 5. So x to the power 5 by 5, and limit of integration is -1 to 1. So if I evaluate it, I will get 3 by 10. Upper limit 1 to the power 5 is 1. Lower limit -1 to the power 5 is -1. So plus 1. So I get 3 by 5 here. 2 by 10, 2 and 10 will cancel, so I will get 3 by 5. So what is the variance? Variance sigma square is expectation of x square, that is 3 by 5, minus expectation of x whole square, so that is 0 square. So what we get is 3 by 5, which I can write as 0.6. So in some of the problems, they may provide you with this mean and variance value, but here they have given the density function. So first part was to calculate the mean and variance, and then we are going to. Now we have this y. So y is defined as x1 plus x2 up to x15. And now I want to show you the statement of the central limit theorem. It tells you, let us look at the statement, that if we have Sn, which I am calling y in the problem, x1, x2 up to xn, then Sn follows a normal distribution with mean n into mu and variance n into sigma square. So here, this, what will be the mean of y? The mean of y will be n into mu. So n here is 15, right? Here n is 15. So I will get 15 into mu, and mu is equal to 0, that I have calculated for the random variable x1, x2, x15. So that I have calculated. So is equal to 0. And what is the variance of y? What is the variance of y? That is n into sigma square. That is the variance of these xi's, right? So n is 15 and sigma square I have calculated 0.6. So if you calculate this, it will be 9 because it will be 6 by 10, so it will be 9. Now what we have to do, we have to calculate the next thing, that this follows the normal distribution. So here y follows the normal distribution whose mean is 0 and whose variance is 9, right? So now I have to calculate the probability for what? We have to calculate the probability that y lies between minus 0.3 to 15, and in the normal distribution video you have seen that this is how the probability is calculated. So y lies between minus 0.3 to 1.5, right? So to calculate it, first of all I have to calculate z. So if y is equal to minus 0.3, what will be the corresponding value of a standard normal variate? That is minus 0.3 minus mu, that is 0, divided by sigma. So here sigma square, the variance is 9, so a standard deviation is under root 9, that is equal to 3. So I will get minus 0.1. And if y is equal to 1.5, then what is z? Z will be equal to 1.5 minus mu, that is 0, by sigma, that is the standard deviation 3. So 1.5 by 3, that is 0.5, half or 0.5. So this problem, if I change into a standard normal variate, this probability will reduce to probability of minus 0.1 to 0.5. And do you remember how to calculate this probability? I am just drawing the normal standard normal curve. So this is how the normal distribution curve look like. And here suppose we have this point that is minus 0.1, and here we have the point that is 0.5. So we have to calculate the area under this curve, right? So using the symmetry, if I call this point 0, I can write it, and see how you have to use this. It will depend upon the tabular value provided in the exam. So I'm going to calculate using the table. Let me first write like this. So this can be written as minus 0.1 to z to 0. So first I am calculating the area in the left of this, means this area, if I highlight it with a different color. So first I am going to calculate this area, right? And then plus the other area, that is 0 to 0.5, right? Now from the symmetry of this, you know that this will be equal to probability 0 less than or equal to z less than or equal to 0.1 and plus probability 0 less than or equal to z less than or equal to 0.5. I hope you understand, because if this is 0, then if suppose I say this is 0.1, then this region will be equal to this region. Now you might be thinking why I am changing it to this, because the table that I am going to use, let me write it over here, and I want to show you the table, that normal distribution table, so that you yourself can decide. So you see, we want the probability for 0.1. So if you look at this question, this value 0.1, the probability is 0.0398. So this value, because if you look at this table, it gives me from area from 0 to z. So that is why I have used the symmetry to write the probability in this form. And the next thing we have to calculate is for 0.5. So for 0.5, it is 0.1915. So 0.0398 at 0.1915. So that what we have to use. So let me write it here. So the probability, this value we have got is 0.0398, and the other value that I have got is 0.1915. So if I add it, the total probability will be 0.2313, right? So the required probability, what is the answer? The answer is 0.2313. So if you look at this, here I have used different concept, and this is a good question. Why it is a good question? Because here we use the concept related to how to find the mean and variance. So this is the one concept I used. Another concept I used is the concept of central limit theorem. So using central limit theorem, I established that y follows the normal distribution, and then we also used the normal distribution to calculate the probability. So very well done. Okay, fine. Next question. Light bulbs are installed successively into a socket if we assume that each light bulb has a mean life of 2 months with a standard deviation of 0.25 months. What is the probability that 40 bulbs last at least 7 years? See, one thing that came to my mind, that if light bulb is just lasting for 2 months, it looks like it is made in China kind of light bulb, right? And you are a person who actually dislikes going to the market again and again. So what you have done, you want to be confident for the next 7 years that you have bought 40 bulbs all together, and you have this experience that the bulb will become dysfunctional or fuse in the next 2 months. So you have bought 40 bulbs, and you are expecting that it will last for at least 7 years. So now the question is that what is the probability that it will last for at least 7 years? So it is given in this problem that if I consider x, that is the random variable which is like the life of the light bulb. So x is the random variable which is the life of the light bulb, right? So x follows a distribution whose mean is given to be 2 months, and whose variance, that is a standard deviation, not variance. A standard deviation means sigma is given to be 0.25. See, it is not given that x follows a normal distribution. It is given that x is a random variable. What is this random variable representing? It is representing the life of a light bulb, right, whose mean is 2 and whose standard deviation is this. Now you have bought 40 light bulbs, so let me call this S40, and suppose the first light bulb is represented by x1, the next is x2, and so you have up to 40, right? So each of these light bulbs will have the expected life 2 months, and their standard deviation will be 0.25. Now we have S40, and we know that for large sample value, usually if the sample value is greater than 30, it will start showing the normal behavior. So I can use the central limit theorem. So central limit theorem tells us what? That S40 follows the normal distribution with mean what? With mean n, means 40 into mu, that is 2, and variance that is 40 into sigma square. So sigma here is 0.25, so I can write 0.25 square, right? So this is what this normal distribution follow. So it means that S40 follows the normal distribution. If I can write with mean 40 into 2, that is equal to how much? That is equal to 80. And this is what? This is 40 into 1 by 4 into 1 by 4. So 10. So 10 by 1 by 4, that is 10 by 4 is equal to 2.5. That is the variance. Now what we have to calculate? We have to calculate that probability that these 40 light bulbs, means in total they will last for more than 7 years. So I want S40 to last at least 7 years, means it should be greater than or equal to 7 into 12, 84. See, don't make a mistake of writing 7, because you have measured the data in terms of months. So here it is 2 months, here it is 0.25 months. So S40 should be greater than or equal to 84, right? So how do you calculate? First of all, for S40 is equal to 84, you calculate the z value, because it follows the normal distribution. So you can convert it into a standard normal variate. So how do you calculate? Do you remember? It is calculated as x minus mu by sigma. So here x that is 84 and mu that is 80 because it follows the normal distribution with mean 80, and variance is this is the standard this is the variance 2.5, so sigma will be equal to under root 2.5. So if you do this calculation, it will be 4 by the square root of this. So if you will calculate, it will be like 2.530. So this problem, probability S40 greater than or equal to 84 will be equal to probability for Z greater than or equal to 2.530. And since we are using the normal distribution curve where the probability in the right of 0 is given, so basically if I call this point as 2.530, so I have to calculate this region probability in the right of it. Means in the table it is given to be the probability from this point to this point, right? So I can write it, this is equal to 0.5 minus probability from 0 to 2.53, right? So I have to calculate the probability in the right, so I will write 0.5, and for this I have to look into the table. So again I am going to show you the table. In the exam usually they may provide this, but here look at the table. So 2.5 is this, 2.50, 2.51, 2.52, 2.53. Can you see it is very small, but it is clear it is 0.4943. So I am writing here it is minus 0.4943. So this value will be equal to 0.0057. So the probability that all the 40 bulbs will last for more than 7 years or at least 7 years is very less. It means that you have to go to market again and you have to buy extra bulbs, right? Because the probability that it will survive for at least 7 years is very less, right? So it is better to buy made in India product which will last longer. So next problem. An electrical firm manufactures light bulb, again light bulb, that have a length of life that is approximately normally distributed. So original random variable is also normally distributed, whose mean is 800 hours. So let me write whose mean mu is 800 hours and a standard deviation sigma is equal to 40 hours. Find the probability that a random sample of 16 bulb will have an average life. Now see, this is not the total they are asking for average life, right, of less than 775 hours. Now I want to show you the central limit theorem statement again, and in this I am going to use the corollary of central limit theorem, that I am going to look at the average life, that is x bar, right? So here it is clear that x bar follows the normal distribution with mean mu and variance sigma square by n. I will explain it slightly again. So suppose there are two parts of this problem, and listen it very carefully. If I ask you that what is the probability that a random sample of 16 bulb, not an average, random sample of 16 bulb will have average will have life of something like maybe 2000 hours or 5000 hours, right? So in that case I will take S16 and there I will calculate there this x16 will follow the normal distribution with mean that is 16 into mu that is 800, right, and then variance 16 into sigma square. So but this is not something that we are looking for here. Here we are looking for the average life, means we are looking for the x bar, right? So here the x bar will follow the normal distribution with the same mean, that is mean will be like 800, and variance, because again look at this statement, the mean will remain same and variance will be sigma square by n. So variance is sigma means 40 square by n, that is equal to 16, right? So this x bar, the average life that is represented by x bar, follows the normal distribution with mean that is 800, and what is variance? If I write it 40, let me write it like 40 by 4 whole square. For our computation it will be easier, right? Now what we have to do, we have to calculate the probability that the average life will be less than 774 hours. So we have to calculate the probability for x bar less than 775 hours, right? So how to calculate probability? If I take x bar is equal to 775, then what will be z? Z will be 775, the standard normal distribution. So for that we have to calculate z. So for 775 it will be 775 minus mu, that is equal to 800 by sigma. So this is sigma square, right? So by sigma will be what? 40 by 4, that is equal to, I hope you have understood this. This is, gentlemen, variance. So if you take the square root of it, it is the square of 40 by 4. So a square root will be 40 by 4, that is equal to 10. So what is z? Z is equal to minus 25 by 10. So that is minus 2.5. So we have to calculate the probability for z less than minus 2.5. And here it is given that probability for z less than 2.5. Here I missed to write the equal sign. So that value is already given, that is 0.0062, right? Because in the normal distribution table here what they have given, if I call this as a normal distribution curve, not looks very cool, but anyway, this point is minus 2.5. So they already have given this probability, and that is like 0.0062. But suppose they give the probability for something like this. They have given this information also. Depending upon what information is available to you, you have to solve it accordingly. So if this information is given, that 0 to 2.5, so if it is 2.5 and this reason is given, so in that case how will you calculate the probability? You have to calculate the probability for z less than minus 2.5. So this will be equal to, using symmetry, probability for z greater than 2.5. I hope you understand. In the left this area and in the right this area will be same, but this area we have to calculate. We have to calculate the area in the right of 2.5. So I can calculate it. 0.5 means total, this is 0, so in the right of 0 the total area is 0.5 minus probability of 0 less than z less than 2.5. So here it will be like 0.5 minus 0.4938. So again you will get 0.0062. See, you don't have to do this and this again. This is depending upon the a statement, or the depending upon the information available in the exam. If the table is available, I can either use this table or the table, whatever table is given, that we will use, right? In case if you have doubt about how this works and all, I would suggest you to watch the video related to the normal distribution. Okay, so 3 problems done. Let us take more problem. Traveling between 2 campuses of a university in a city via bus takes an average 28 minutes with a standard deviation of 5 minutes. So it is given already that mean mu is 28 and a standard deviation sigma is 5. In a given week, a bus transported passengers 40 times, right? What is the average transport time? What is the probability that average transport time was more than 30 minutes? Now look at this very carefully. The bus is traveling 40 times, right? So if I use the central limit theorem on Sn, suppose I say that it is x1, not Sn, I can call it S40. So it is x1, x2 up to x40, right? But in the question they are asking that suppose the bus is commuting 40 times in a week, what is the probability that average time, means not the total time, the average time was more than 30 minutes. So first of all, if you use the central limit theorem and I call the average time as x bar, this will follow the normal distribution with the same average, that is mean, that is 28, and variance. So variance is sigma square by n. So it will be sigma is 5, so sigma square is 5 square, and by n, so n is 40 because the bus is commuting 40 times. Okay, I hope there is no confusion in this. Now if I have to calculate what probability I have to calculate, that probability, what is the probability that average transport time was more than 30 minutes. So I have to calculate the probability that x bar, that is the average transport time, was more than 30. So first of all, I have to calculate the standard normal variate, that is z. So if x is 30, what is z? Z is 30 minus mu, that is 28, and by sigma, so sigma is under root of this, so under root of this will be 5 by under root of 40. So if you calculate this value, it will be like 2.53. I would suggest you to calculate this value, 30 minus 28, 5 by under root 40, so it will be 2.53. So probability for x bar greater than 30 is equal to probability for z greater than 2.53. And now I would leave this for you, that you check into the normal distribution, or let me write it. So this can be 0.5 minus probability 0 less than z less than 2.53, and that will be like 0.5 minus, I hope by now you are all confident that if I look at the normal distribution curve, we have to calculate, and if I call this point as z is equal to 2.53, I have to calculate the probability in the right of this. So I can calculate the total probability in the right of 0, that is 0.5 minus this probability. So this probability I can check from the normal distribution table. Where is the table? If I look at the table, 2.53. So if you look at 2.53, it is 0.4943, right? So it is 0.4943. So I will get 0.4943. So this probability will be equal to what? This will be 0.0057. So this is how you solve the problem, right? I hope things are becoming very clear and you are enjoying the video. Okay, so let us quickly take few more problems. So if you look at this problem, if x1, x2, xn are Poisson variate with parameter lambda is equal to 2, use central limit theorem to estimate the probability that Sn, which is defined as x1 plus x2 plus xn, and n is equal to 75. So we have to calculate this probability. Now we had already given that Sn will follow the normal distribution. Sn will follow the normal distribution. What will be the mean? Mean will be n mu and variance will be n sigma square. This is the statement. I also want to show you the statement again and again. I hope you are getting confident. See, here Sn follows a normal distribution with mean n into mu and variance n into sigma square as n tends to infinity. So here n is large, 75 is large. You may say that it is not very large, but usually in statistics or probability statistics course, if sample size becomes more than 30, we consider it as a large sample, right? So Sn follows the normal distribution with mean n mu and variance n sigma square. So first of all, what is n mu? N mu is equal to n is 75, and what is the mean of these variables? This follows Poisson distribution with mean, that is lambda is equal to 2. So lambda is equal to 2 is the mean, and you know for Poisson distribution the mean and variance are equal. Do you remember this? So lambda mean will also be 2, variance will also be 2. So mean of Sn will be 75 into 2, that will be equal to 150, and variance will be n into sigma square, so that will be 75 into sigma is 2, means that is also lambda. So here I am using lambda for mean of Poisson distribution, but in general notation we use mu and sigma square, so there is no need to worry. So I can write 75 into 2 square, so that is equal to how much? That I think 4 into 75, that is 300. Okay, n into sigma square. Now what is the next thing we have to calculate? We have to calculate so this Sn follows the normal distribution, and we have to calculate the probability that Sn lies between 120 to 160. So we are very confident now that if Sn is equal to 120, what will be the z value? So z value will be 120 minus mu, which is the distribution that is following. So for this, let me write again. So Sn follows the normal distribution with mean 150 and variance, that is sigma square, so 300. Okay. I think there is a small mistake that I have made here. Can you identify the mistake that I have made? That variance is 2. So why am writing 2 square? It will be just 2. Yes or no? So it will be not 300. It will be 150. Sorry. And so here also I have to write, in place of 300, I have to write 150, because I was looking at like a standard deviation. So this is 150, right? So mean is 150 and variance also is 150. So it is 120 minus mu, that is 150, and by sigma. So this is sigma square. So I will write under root 150. So if you do this evaluation, you will get minus 2.45. I would suggest you to do this. And if Sn is equal to 160, the Z will be what? Z will be 160 minus mu, that is 150, by the square root of variance, means a standard deviation, so under root 150, and this value will be equal to, if I can calculate this value will be equal to 0.82. Let us verify whether it is correct or not. So what is the probability now? So this probability will be equal to, this will be equal to probability of, for minus 120 I have got minus 2.45, less than or equal to Z, less than or equal to 0.82. I want you to solve it yourself using the table, right? Can you use the table? If I have to use this table, or let me write, basically if you look at the normal distribution curve, it will look like this. So we have to this point, if I call minus 2.45, and this point if I call 0.82. So I have to calculate the total probability. So this probability I can directly check from the table, and to calculate this probability I can use the symmetry, right? So I can write like probability of minus 2.45 less than or equal to Z, less than or equal to 0, and plus probability for 0 less than Z less than 0.82. And if I have to calculate the probability from minus 2.45 to 0, this will be equal to the probability from 0 to 2.45, right? Because normal distribution curve is symmetrical, and plus probability from Z0 to 8.2. So if I look into the table, I leave this. I just want you to look into the table and decide that what will be this value. So if you look into the table and decide this value, I will get the answer like 0.7868. I sincerely request you that please check the table, because at least you will have the understanding that how to check the table, right? I could have written it, but I have avoided, right? Okay, so let us take another interesting problem. A distribution with unknown mean mu has the variance equal to 1.5. So let me write the information here. There is a random variable x whose distribution is unknown, but it is given that expectation or mean is mu, which is unknown, and variance of x is given to be 1.5. Use central limit theorem to find how large a sample should be taken from the distribution in order that the probability will be at least 0.95, that the sample mean will be within 0.5 of the population mean. So sample mean, let us call it x bar, and from the central limit theorem we know that x bar follows the normal distribution with mean mu and variance sigma square. So here sigma square is given to be 1.5, so 1.5 by n, and in the question we have to find this value of n, right? What is given? It is also given that we are going to find n in such a way that probability that the x bar, the mean, lies mean lies within 0.5 of the population mean. So this is our population. So if it lies within 0.5 means what? That the x bar should be less than mu plus 0.5 and it should be greater than mu minus 0.5. I hope you understand this. If I say that a particular number, suppose understand it through this explanation, that suppose I say that find all the numbers which are lying within 0.5 of alpha, means we have to take those numbers which are uh, coming between alpha plus 0.5 and alpha minus 0.5. So I am going to take all those numbers which are in this interval. So I will say that these numbers are within 0.5 of alpha. So here x bar should be within 0.5 of mu, means x bar should lie between mu minus 0.5 to mu plus 0.5, and the probability of this should be at least 0.95, means it should be greater than or equal to 0.95. Okay, now let us proceed further. So if I look at this thing can also be written as x bar minus mu, that should lie between minus 0.5 to 0.5. Will you agree to this? I hope you will agree, because here I have taken mu in this side, or so it will become x bar minus mu, and so the difference between x bar and minus mu should be, someone can directly write this also if he is clear, that if it lies between within 0.5 means the difference of x bar minus mu should be lie between minus 0.5 to 0.5. Now one thing I want you to understand, that this term, that if you look at and if you recall the standard normal variate, it can be calculated by using this formula x bar, if I am considering that x bar is the normal variate. So x bar minus mu by standard deviation, that will be equal to a square root of 1.5 by n. So what I am going to do next is I am going to divide all the three terms by this term, that is minus 1.5 by n square root, because I want to change it in terms of a standard normal variate. So this expression will become 0.5 by under root 1.5 by n. This will be less than x bar minus mu by under root 1.5 by n, and this will be less than 0.5 by under root 1.5 by n, and this probability should be greater than 0.95. Now if you look at this term here, this is nothing but z, right? So I can write probability, and here I also want you to remember one thing, that if somewhere I am writing minus a is less than x is less than a, then this is nothing but mod of x less than a. So this thing is z, right? So I can say that this z whose mod is less than a, that is 0.5 by under root 1.5 by n, this value is greater than or equal to 0.95. I hope you have not missed any point. Now there are two things that I am going to talk about. One is, and this is a standard, this is a star point I am highlighting, that if you look at the normal distribution curve, this is how it looks like, right? And this is a important information, that 95% of the area under the normal distribution curve lies between minus 1.96 to 1.96, right? This information can be written as what? That probability that mod of z is less than 1.96 is equal to 0.95 if z is a standard normal variate. And there is another similar result. We will be using this in the next chapter, testing of hypothesis, that if I take the point like minus 2.58 to 2.58, then probability that mod of z is less than 2.58, this probability is 99%, like 0.99. right? So here if we look at this statement, this probability that I want to calculate, that should be greater than or equal to 0.95. So for what value of this expression, if I take this expression equal to 1.96, then the probability will be equal to 0.95, and I want the probability to be greater than or equal to 0.95. So what I do, I take that since I write it, since we know that, and this is something that you have to remember, they may not provide you in the exam, know that probability of mod z less than 1.96 is equal to 0.95. So if I take what I take this 0.5 by under root 1.5 by n is equal to 1.96. Then what will happen? Then from this I am going to calculate the value of n. So I write 0.5 into under root n by under root 1.5. This is equal to 1.96. So under root n will be equal to 1.96 into under root 1.5 by 0.5. So n will be the square of it. So if you do this calculation, you write n, this will be equal to something like 0.23.06 approximately. Can we just verify it quickly? So you do the calculation, you will get n is equal to 23.06. So for this value of n, this probability will be equal to 0.95, but I want the probability to be greater than or equal to 0.95. So what size of sample should I take? So if I sample size cannot be taken as 23 point something, I want the probability to be at least 0.95. So certainly the n should be greater than 23.06, greater than or equal to, because n is an integer, where let me write say n is an integer because the sample cannot be like you can't take 23 and half sample, either you take 23 sample or 24 sample. So here I write that the value of least value of n will be equal to 24, right? So n will be 24. If I take n is equal to 24, then in that case the probability that the sample mean will lie between 0.5 of the population mean will be 95% or more. Okay, so this is another interesting problem. I hope you liked it. So with this I complete this central limit theorem. We have discussed many important problems. So please share this with your friends, and in case if you find any difficulty or any point which you feel like you have not understood, so what you can do, you can put it in the comment section, but I would suggest you to put the comment with a time stamp. Otherwise it is very difficult for me to understand that what you are talking about. So just put the time stamp and say that at this point I have a doubt, so possibly I will be able to explain it, right? So that's all from my side. Thanks for watching. From the next video I'll be uploading the testing of hypothesis. Okay.